Let's do one more example. So at 2 p.m., a car's speedometer reads 30 miles an hour, and 10 minutes after, at 2:10 p.m., it reads 50 miles an hour. Show that at some moment between 2 p.m. and 2:10 p.m., the acceleration is exactly 120 miles per hour square. So how to do this problem? We don't really have a lot to work with, and actually it's interesting that says show that at some moment, okay, that is not telling you find the time, find the moment. It's saying at some moment. So that gives a hint that we may want to apply the mean value theorem here actually. Why? Well, we are looking at the velocity, right? The velocity function. Okay, which we can assume is differentiable, no problem. Then the mean value theorem is going to say that there is a value C, okay, in some interval AB, open interval, such that V of B minus V of A divided by B minus A equals B prime of C, which is the acceleration. Okay, this still doesn't link exactly to 120 miles an hour square, but see what happens. So when we look at all the data we have that at 2 p.m., which we can say it's t equals 0, that's our 2 p.m. And then we have our 2:10 p.m., which is t equal 1/6 of an hour. Okay, and we have our v of 0, which is, how much was that? Was 30. And then v of 1/6 was equal to 50. So see what happens here. V of B minus V of A divided by B minus A, this is 50. Let's take A as 0 and B 1/6. Okay. So we have, let me write it carefully, V of 1/6 minus V of 0 divided by 1/6 minus 0, and that is 50 minus 30 divided by 1/6, so that is 20. 20 divided by 1/6, that makes 120 miles per hour square. And actually reading back, it says at some point the acceleration is exactly 120 miles an hour square. But actually that is what the mean value theorem is saying. The mean value theorem says there is C in AB, which with our choice is 0, 1/6, okay, which is the time between 2 and 2:10, 10 past 2. Okay, so there is C such that A of C, the acceleration at that precise time, is 120 miles an hour square.